Welcome to The Explainer. Today, we're going to pull back the curtain on a tale of two identifiers. These are the hidden digital fingerprints that work tirelessly, behind the scenes, to keep our massive computer networks from just collapsing into total chaos.
Okay, so let's just dive right in. I want you to imagine a whole fleet of servers. They're all identical, all clones of each other, holding copies of the exact same critical data. Now what happens if one of them has slightly different information? How does the network figure out who to trust? This is like a fundamental problem in any distributed system. How do you establish identity and how do you make sure the data is legit?
So to solve that first part of the problem, telling which server is which, Microsoft's Active Directory gives each server a permanent, totally unchanging identity. Seriously, think of it like a social security number for a server. It's unique and it is for life.
Now, this identifier has a fancy name, the Directory System Agent Globally Unique Identifier. But we're just going to call it the DSA GUID. Its entire job, its whole reason for being, is to be this one stable anchor point. It's how other servers can always find it, and it's how the system can track every single update that ever comes from it. It's basically the server's true name.
And this is what's so wild about it. This ID is permanent. I mean, look at this. When a server is first brought online, boom, it gets its DSA GUID. You can rename the server, you can restore its entire database from a backup, and that GUID doesn't budge. The only way it ever goes away is if you completely wipe Active Directory off the server. It is truly built to last.
But just having a permanent server ID isn't quite enough to solve our trust problem. The network also needs to know the specific version of the data on that server. I mean, what good is knowing who a server is if you can't trust what it's saying, right?
And that's where our second identifier comes into the picture, the Invocation ID. Now, this isn't an ID for the server, it's for the database on the server. You can think of it like the version number on a passport. Your identity as a person doesn't change, but if you get a new passport, it has a new issue number to mark that specific version. The Invocation ID, it does the exact same thing for the database.
So here's the crucial point, right? Unlike that rock-solid DSA UID, this identifier is specifically designed to change. It's dynamic. Its main purpose in life is to signal a major shift in the state of the database, and most importantly, after a restore from a backup. It's basically a warning flag that the data's history has been reset.
All right, so let's put these two head-to-head. Let's really see how this clever dual identity system works together to maintain order and trust across the entire network.
Yeah, it really all boils down to this. You've got two numbers, two totally distinct identities, and they're working in perfect harmony. If you took one away, the entire system of trust would just fall apart.
And this table just lays it all out so perfectly. The DSA GUID is all about the server itself. It's permanent. It never changes. The Invocation ID, that's all about the data. It's temporary, it's tied to a specific version of the database, and it has to change when that history gets altered. So one tracks the machine, the other tracks the data's timeline.
So you might be asking, why does having a changeable ID matter so much? Why go through all this trouble? Well, the payoff becomes crystal clear when things go really wrong. It all comes down to disaster recovery.
Okay, picture this. It's a sysadmin's worst nightmare. A key server just crashes. Your only option is to restore it from last night's backup. But think about it. That backup has old, stale data. And if you reintroduce that old data to a network that has a whole day's worth of new changes, well, that could be catastrophic. You could wipe out critical updates.
This is where the magic happens. When that server is restored, the system generates a brand new Invocation ID. The second it comes back online, its partners look at it and they essentially say, "Hey, I know your permanent ID, but I've never seen this version stamp before. You must have old data." That new ID is a signal to the whole network that screams, "I'm out of date. Please update me." So instead of overwriting good data, the network floods the restored server with all the changes it missed. It's brilliant.
And that's the whole point. That simple change, that's the key safety mechanism that protects the integrity of the entire directory. It allows a server to be brought back from the dead without poisoning the rest of the network with outdated information. It makes sure everybody stays on the same page.
So the main takeaway here is this really elegant two-part system. It brilliantly separates the identity of the machine itself from the identity of its data. The permanent DSA guide makes sure we always know who we're talking to, while the dynamic Invocation ID makes sure we can always trust what they're saying.
It's just such a fascinating solution to a really complex problem. And it makes you wonder, doesn't it? What other crucial, hidden identifiers like these are out there?
working tirelessly behind the scenes, just holding together the invisible threads of our digital lives. Thanks for watching.